Vector search involves representing each document or paragraph by an arrow, and that direction represents its meaning. Then you can do a search by also representing your query as an arrow and finding the documents that have a similar alignment. This is a very powerful technique, and I see many implementations that will rely solely on this to find the most relevant documents or paragraphs to include in an LLM query. But you should know that the highest quality implementations of search with LLMs will also use traditional techniques that are based on keyword search. So I'm going to describe to you the pros and cons of pure keyword and pure vector search approaches, and why you might want to consider one, the other, or even both. I'll start off by giving a quick review of how vector or embedding search works, how keyword or best match 25 search works and why they're different. Then I'm going to talk about some things to appreciate around searching for different languages, organizing long documents, getting high performance on new or infrequent words, which is a pretty important use case for most applications, doing search with humans or with LLMs and why this is a bit different, and using pagination, which I think is a trick that's pretty old but underappreciated in modern LLM usage. Last of all, I'll cover the latest on the best libraries to use if you're going to do a Postgres implementation of a database. I love Postgres because it's open source, and I think many others do too. You can, of course, use private services, but I found they often will add latency to your queries as well as adding in cost and sometimes complexity. So if you understand the libraries that are available, just turnkey from Postgres for doing vector search and for doing BM25, this is going to help you get started a lot more quickly. And there is, by the way, a newish library called VectorChord BM25. It's a Postgres native implementation of Best Match 25, which is a keyword search technique. So I'll show you quickly how to implement that. I'll also show you how to implement it with vector search in a hybrid technique called rank fusion, which allows you to combine the two metrics in order to get one single ranked list of the documents that are most relevant. What is vector search? It means you convert a string of text, could be a very long string like a document as well, into a vector, which is an arrow. Here I have a two-dimensional arrow, and this is representative of its meaning. And you have a model that allows you to do this conversion. They're typically small transformer type models. They run quickly, and they are trained on bodies of text along with usually a title. So often if you have, say, a Wikipedia page, it's got a title and it's got lots of text, and you can train the model to associate the arrow representing that text with the arrow representing the title of the passage. So for example, here I have a query, what animal is tallest? I have a vector, and then I have a vector for giraffe, which might point this way, and rabbit, which might point this way. And vector search works by considering which of these two vectors is pointing in the most similar direction to the query vector, and picking that as the most relevant string that you might then include in a query. So the approach is you convert using a model into vectors and use those vectors to find the closest base paragraph or document. And this is a meaning-based approach. It doesn't do any exact letter comparison, any exact word comparison. It purely compares the meaning of your search query with the meaning of each of your chunks or your documents. By contrast, we have keyword search. Now, keyword search, you've all done Control F in a PDF. Literally, it's an exact match for what you're searching for. With Control F, you can sometimes turn on capitalization sensitivity or not. So that allows you to maybe match words that are the same but are in lowercase. And you can think of Best Match 25 or BM25 as keyword search on steroids. So it does a few things. First of all, it converts the queries and the paragraphs into subwords or tokens. So you can think of this as cleaning. For example, if you have a query, what animal is tallest, it will split that into what, animal, and tall. This here is called stemming. It's where you remove kind of these last parts of words that help you to get a more general representation and improve your matching. And there are different approaches you can use for tokenization or stemming. Second step is, for each document, you count the frequency of each word in the query, and you do the same for each document. So here, for example, we'll have a dictionary that says what appears once, animal once, tall once. Here we've giraffe once, once, tall once, animal once. Then basically, very loosely, the formula for BM25 will ignore words that are very common everywhere. So for example, the word are, because it's present in these two paragraphs, that's going to be common, and it's not really useful when we compare, sorry, R is a bad example because what it will think of is the query words. So here, if I look at the query, I've got what, animal, and tall. Maybe what is appearing a lot in tons of documents. So it's not very useful to see if the word what appears in a given document. It's just too common. We're much more interested in whether these specific words appear. So by using frequency across the document corpus, you can say, ignore any common words when we want to find matching documents. Effectively, we actually weight them, but consider instead words that are rare in the query, query words that are rare across the document corpus, because that's going to give a strong signal. So this is how BM25 works. It focuses on finding words that are in the query but are rare across the documents, because that provides high signal. Now notice that this is still based on exact match. The exactness is kind of made a bit fuzzy or a bit more, let's say, pliable by lowercasing all the words and then by stemming them or using the more common representations. And this helps a lot. And you can use advanced techniques that will even adjust for the present or past tense of the words. But it is ultimately a more exact match technique, which will come with pros and cons that I'll describe a bit later. So a few things to appreciate if you're looking at doing exact match techniques like keyword or BM25 versus vector. The first is searching in different languages. If you do a vector search, remember an arrow is just representing the meaning. If I look for the word, I don't know, elephant, and that is probably going to point in the same direction in a German corpus of words or a French corpus of words. So I am probably going to find documents if I search for elephant that will transcend my body of documents. Meanwhile, if I literally work for ELEPHANT in a multi-language document set using BM25, well, elephant is spelled differently, so it's not going to pick up the representation of elephant. It's just going to pick it up in whatever language I query in. So this is just important to know. It's not necessarily better to do one or the other. It depends on your use case. It could be annoying to get results in different languages for the same term, because you might have, say, top 5 results and they're all just giving 5 different languages, which means you're missing some of the results that might have been returned in English in the other languages. But on the other hand, if you do want documents across multiple languages, then BM25 is not going to work unless you ask the LLM to query in both languages or include keyword search terms that are in both languages or whatever number of languages you need. The next thing to be aware of is long documents. So vector search requires a model in order to get a vector for that paragraph or document. And you can deal with quite long documents. For example, the nomic embedding model is 8,000 words. This is a fairly common length. But if you have a document that's longer than this, you're not going to be able to get a vector representation. Now, you could cut it into chunks and then average the vector across those chunks. That's kind of a very rough way. It's not going to be benchmarked with respect to performance. So generally, vector search is going to limit you in the size of chunks that you have, whereas BM25 will work for any length document. In fact, there's a length normalization term that kind of normalizes for the fact that longer documents will have a tendency to include more words. And if you normalize for that, you can kind of get the right balance of relevance. So BM25 is a lot easier to implement. You have tons of documents. You can just index each document separately, not worry about the length. It's going to be faster and lower memory for lots of large documents. Furthermore, if you have some kind of document and you really think that document is relevant, but as a whole, but it's not particularly relevant if you just look at individual paragraphs, well, vector search may not rank that document's content very highly, but BM25 might pull that up. So BM25 allows you to be more holistic in a sense about documents. So for that reason, often if I build a database, I'll consider just doing BM25 as my first layer of search. And if I want to search within the document, maybe I consider using vector search and or BM25 as well within. Basically, I always like including BM25, and then I will sometimes add in vector search to allow for some semantic search on top of that. Next thing to appreciate is new and infrequent words. I think this is definitely underappreciated because when you look at benchmarks of performance on embedding retrieval, they're often benchmarks for things that are known to LLMs. And so that's not going to be applicable in the real world necessarily. Often you will have an application that is somewhat nuanced. I mean, if your application is not that nuanced, you're probably just directly competing with ChatGPT or language models that are out there. So often if you're building a business, it's because there's an opportunity to do something nuanced. And if that's the case, then you probably want to be able to generalize beyond what the corpus of data that the LLMs or the embedding models are trained on. And vector search will just fail if there are new terms that the embedding model is not familiar with, because it's not going to find them. Whereas BM25, if you have a new term, as long as it's spelled correctly or is getting tokenized correctly, and by the way, you can easily build a custom tokenizer for new terms. That's a lot easier than, say, training an embedding model or fine-tuning an embedding model. BM25 is going to work out of the box, and it's going to generalize a lot better. So I think this is underappreciated. If you want generalization, it's going to be smart to include BM25 within your implementation. Something else to appreciate is that LLMs are increasingly doing search for us instead of humans writing queries, and LLMs are better at writing queries, and this turns out to increase the advantage of using, it increases the performance of BM25, because BM25, it matters how well you write the query. For example, if you make a spelling mistake when you're using a keyword type search, if you search for Ronan, but you spell it with an I at the end, R-O-N-I-N, you're not going to find me because I'm spelled with an A if you're using keyword search. However, LLMs do not make as many mistakes in spelling as humans. And further, you can prompt them to rephrase user queries. For example, you could get them to provide keywords, multiple keywords for the same original keyword. Like maybe you have a word like, I don't know, happy, but you could ask the LLM to use related words too. So it would also include in the query happy, content, in a good mood or good mood. I don't know, they're two words, so it probably doesn't work well. But broadly, the LLM can be prompted to provide a more expansive query. That's a technique called query expansion. And this is going to help with the relative performance of BM25. So I always recommend when you're using an LLM to do searches, like say you have an LLM that's an agent or doing retrieval, explain to the LLM exactly what your search methods are so it knows how to optimize its queries. And last thing, I talked about this recently on one of my videos about memory management in LLMs, but pagination I think is underappreciated. When you search in Google, you see a page of results. And if you have something rare, maybe you don't see it on the first page, so you just go to the next page. And this is pretty powerful because it allows the LLM or the human to be exhaustive. You can just keep moving and paginating through pages and get more information. The alternative is, and this is very commonly done with RAG or retrieval methods, you just get the top 6 or the top 12 paragraphs. And so if you miss the content in those, you just have no chance for the LLM to get it. Now, sometimes you can do iterative approaches where you let the LLM search again, but maybe it just needs to literally page to the third page and find that result. And by tweaking its query, it's not going to manage to get that third page result. So I think the option of pagination is something that's underappreciated in these retrieval systems, and it's fairly powerful. You can check the memorization video I made recently if you want to see a bit more on that implementation. Now, I will talk about libraries. There's one other thing I want to say first, which I sort of said before, and that's around performance on new or infrequent words. I definitely recommend doing keyword BM25 for generalization, but if you want some embeddings that generalize a bit better than traditional embeddings, you can look at CDE, that's contextual document embeddings. It requires you, when you embed a given phrase or document, to also provide a reference set of documents. And this kind of directs the model in its embedding to point the vector in the right direction. I give a full explanation of how CDE works and also how to fine-tune those models in a video on CDE models. So it's actually in my Modern BERT video, which I'll just link up here now. Okay, with all of this said, you know I'm a big fan of Postgres because it's open source. A lot of companies already use it. It's easy to implement. You can run it directly on your own server, so you don't have server-to-server communication using an outside third-party embedding service. And it also has some libraries that directly allow you to do fast search. So for vector, you can either use pgvector, you store your vectors and use pgvector to do cosine similarity or dot product using that library. And it allows you to index your database, which means sort it. What's it called? Hierarchical Navigable Small World, HNSW, which means that you have tons of arrows and they're grouped into clusters, and then those clusters are subgrouped. And so when you do a comparison of two vectors, you actually don't compare vector A with the full database of vectors. You compare it with the clusters, maybe 3 clusters. You find the one that's closest, then you zoom in on that, find the one that's closest. So you get this hierarchical logarithmic type search approach. That's going to be a lot faster. So that's why you want to use something like pgvector. There's also pgvecto.rs, which is a Rust implementation. And then for for best match, there has been a library, and it's still there, called pgbestmatch. It uses pgvector or pgvector.rs, but it does not provide for indexing. I think there's maybe some way to use kind of an external v-based approach, although that's actually maybe a separate library. But either way, there's now a library that is native to Postgres called VectorChord 25, and this one implements indexing. It's a custom type of indexing that allows for fast search. Now, the reason you can't use pgvector with hierarchical navigable small world is because when you have sparse vectors, so basically in bestmatch 25, you've got a dictionary of term frequencies for each document, and that's called sparse because each document does not necessarily contain every word. It's not efficient, or it's not effective. It's rather not effective, actually, to try and cluster based on these sparse dictionaries because there's not really enough overlap between the different dictionaries. So you need some different way to index, which I'll talk about briefly in a second. But VectorChord 25 implements this. So now there's basically a native way to do the embeddings and also to do the BM25 within Postgres that I'm going to show you in code just now in a second. Just briefly on how the indexing works. I'm getting kind of technical here, but I'll keep it brief. The indexing in tensorchord is done, let me see, have I got this? Yes, it's done using a method called Block-WeakAnd. And how this works is you can think of documents here that have got, in this case, they've got scores, which you can think of as BM25 scores for different tokens, but you can think of these maybe as frequencies for different tokens. And instead of requiring a comparison with each individual document, you group the documents into blocks. And you basically sum together the document statistics for the documents in that block. And by doing that, you can now first look at the blocks and use that as an upper bound of how any document within that block will perform. So essentially, instead of comparing every single document, you now reduce this to a problem of looking at blocks. You find the blocks that are going to be the most relevant to your BM25 search, and then you can look within those blocks. So it's a little bit hierarchical, but it's not hierarchical in the sense of clustering arrows. It's hierarchical in the sense of gathering and combining the statistics for BM25. Now, there's one other thing I'll comment on here, because I'm going to show you first the BM25 implementation using VectorChord, and then I'll show you a quick implementation that combines vector search and BM25. And when I combine the two, you have to decide, how do you want to pick the most relevant chunks? Do you take the top 3 chunks from BM25 and the top 3 from vector search, or do you do something else? And there's something else you can do. And thanks, I think there was a comment by Rasmus on my more detailed video on Postgres and BM25 and vector search. But he recommended, and it's a good recommendation, is to use rank fusion. So let me just take a quick look here at the rank fusion method. So rank fusion, or reciprocal rank fusion, it merges 2 independent methods, and it does so purely based on rank. You see, the problem is if you just give a weight to each of the methods, like 50% each, the range of scoring is completely different for BM25 than for cosine similarity or dot product on vectors. So if you just naively try and pick a weighting, which actually probably a lot of implementations do, there's no real reason why you should weight one versus the other at a particular weight and why that would generalize. So it can be more robust to just look at the rankings. So you take the rankings of BM25 and the rankings of vector search, and then you combine those on a ranking only basis by using this formula here, which basically sums together 1 over the rank. So if the rank is lower, it gives a higher weight. And then you also have this factor K. K is a constant that's usually maybe about 100 or something like that. And it avoids you from having too much difference in weighting between the first rank, the second rank, the third rank. So instead of being 1 over 1, which would be 1 point, it would be 1 over 1 plus 100, which would be 0.0011, I guess, in terms of importance. but that will still be more importance than the second rank, which is 1 over 100 plus 2, which would be a little bit less than that. And sorry, I think I've got that backwards. It would actually be 0.0099 if it's 1 over 100 plus 1. Okay, so this is how I'm going to combine them together. But first, let me just show you how to implement BM25 on its own. I'm going to do that by looking at the Advanced Inference repo, which you can get at trails.com/advanced inference. You can purchase membership to this repo, which I'm going to show you now over in Cursor. So I've cloned the repo. There are a ton of different scripts here, including the very detailed implementation of RAG in Postgres, which I recommend here. And right at the bottom, there's now a new folder called VectorChord BM25, which we're going to have a quick look at now. So I'll take you through how this VectorChord BM25 works. You can find the repo here. I'll link it in the description. As I said, it's a native Postgres implementation of doing BM25. You can run Postgres in a Docker image. This is actually a nice way to do it. If you can install Docker, it avoids you having issues that are different between Windows, Ubuntu, and Mac on running Docker. You can, of course, run Docker directly if you like. So I'll just run this Docker image here. And now that it's running, I'll connect to that database on port 5432. And I'll enter my password. And next, I'm going to create the extension for VectorChord BM25. So let's do that. And you have to set the BM25 catalog to the search path. So this means that the search is going to look in BM25 catalog, which is what you want. Now let's create a quick demo table of documents. It's going to have text, and it's going to have a BM25 embedding vector, which is a sparse vector. So I've created that table, and I'm going to put in some sample documents here talking about Postgres. Now, once the text is in, I need to tokenize it. And this library uses BERT to tokenize. You could also tokenize by lowercasing it, splitting text into words, stemming them, using more advanced techniques. And you can find out more about that in my video on Postgres RAG. But for now, we're going to tokenize with BERT, and then we're going to create an index. So when we do this, it means we're going to have the statistics, and we're going to have those statistics indexed according to that method. Sorry, I don't remember the name of the method. It's Block-WeakAnd. So that's now created. And then we're going to do a BM25 search. So this here indicates that we're going to use, I think it's a custom type of search as opposed to cosine or dot product. And we're going to search for Postgres SQL in the document embeddings. And you can see we're going to use the BERT column of data. So let's take a look at that. And here you can see that we've got the passage, and we've got a BM25 score for each of those passages as it relates to the word PostgreSQL. And unsurprisingly, the word PostgreSQL is contained within all of those retrieved passages. So then you can try alternative searches. So you could look for the word, say, search ranking. And yeah, unsurprisingly, it's pulling up the word search ranking right here. Now, let me very quickly show you a hybrid search example. This is going to feel fast, but if you want to understand more, you can go back to the Postgres RAG video and you can look through all of the details. There are some nuances that are important to understand around, particularly the tokenization, I would say, but also around speed implications. So for this, I'm going to take a look at this hybrid search example that I've built. It's going to require me to embed. So I basically have to do everything I showed you for BM25, but I additionally need a column of embeddings. And to get those embeddings, I'm going to use this embedding modern BERT from Nomic. It's a fine tune of the modern BERT model. It supports up to 8,000 in length. By the way, length is something you do need to manage if you have long documents. So I do talk more about that in the Postgres RAG video. But broadly, I need to use this embedding in this embedding model in order to create the embeddings. And then I use that embedding column indexed according to clusters with hierarchical navigable small world. and then that allows me to get my vector rankings. So I've got functions here for processing the embeddings, embedding the documents, embedding the query. Just a note that with Nomic, you actually need to prefix your chunks for documents with search document and the query with search query. I have a function to connect to the database, set up the database. This is doing the setup as what I showed you before, but I'm also now setting up, PG Vector. So you'll see there's setup here for the BM25, but there's also going to be setup for PG Vector, which should be here. So you can see we've got space in the table for the dense embedding vector, and then we're creating an index, not just with BM25, but we're also creating an index using hierarchical navigable small world on the dense embeddings on a cosine similarity basis here. And by the way, these are parameters here around the group sizing of the hierarchical navigable small world. We've got some, I think, fairly standard defaults. Then we insert documents like I showed you earlier. We get the dense embeddings and we write those into the document database. So we're inserting the document with empty embeddings, updating with BM25, and then adding in the dense embeddings that have to be calculated. Now, the last thing is to calculate how to do a hybrid search. And that means we do the vector search, we rank, we do the BM25 search, we rank, and then we fuse them together using that formula of 1 over the 1 plus k, or sorry, the k plus index formula. So here we're getting BM25, we're getting the vector similarity, and then we combine the results with this 1 over the k plus the vector rank formula here. So I know I'm going through this fairly fast. Basically, when we run main, it's going to set up the database, insert the documents, and perform the search, which is what we want. And furthermore, let me just exit here from Postgres. I think I probably can just start up a new Postgres Docker image just so that everything is clean. So let me grab the Docker image that has been started. Let's do Docker stop. You don't have to do this. You could figure out a way to just use the same Docker image, but I want to run it exactly the way you would run it. And to do that, I'm going to start up a fresh Docker instance using this script. So I'll start up a Docker container for VectorChord hybrid, make sure everything is running, connect to the database, and then basically I'm just going to run this script here, the hybrid search example. So you'll need to run chmod +x and then run hybrid search.sh. Sorry, I didn't increase my screen size earlier. And you need to be in the right folder too. So VectorChord BM25. So now we can apply the permissions and then just sh hybrid search.sh. All right. Created a virtual environment. We've installed the dependencies. By the way, there are a few dependencies I'll just show you right here. So we're going to use psychopg. That's to connect to the database, sentence transformers in order to do the embeddings. The reason I'm using a model, I'm literally downloading it and running it on my Mac. It's fine because it's a small model. In production, though, if you're doing a lot of vector creation, you probably want to hit an endpoint. You can see Postgres RAG for how to do that. Like use a third-party endpoint from Nomic or from OpenAI. Then we need Torch, NumPy, and HF Transfer does fast wait downloads. So we're starting a new container. Postgres starts up. The database is being set up, and we run a hybrid search. So that's all moving fairly fast. But the hybrid search we're doing for is Postgres QL search using the rank retrieval rank fusion. K is equals 60. That's, I said 100 earlier in the denominator, but 60, 60 to 200 is probably fine. And you can see the passages that are retrieved. So there's a BM25 score. The most relevant passage overall is considered to be this one. It's got the highest retrieval rank fusion score here, 0.32787, which is higher than this. Note that it includes, in this case, both methods. So both methods are very aligned, as it turns out here. The vector search and the BM25 think that they think the same passage is the most important one. But then the second most important passage overall turns out to be ranked second in BM25 and third in vector score. The third most important is fifth by BM25, second in vector score. So you can see it's merging together the results of both methods to give us a meaningful final method here for the retrieval rank fusion. And that is it for this video on deciding how to do keyword versus vector type search. I said the scripts are in advanced inference. There are probably some things that would be interesting to appreciate that I haven't covered here. So let me know in the comments and I'll reply to them. And as usual, let me know in the comments too if you have any questions. Cheers, folks.